Okay, shout out to Liz. We miss you, and Rowan, and Anna, and Morgan, and Rianne, and Eve. And yes, we miss you. Um, yeah, check it out. Okay, so the big question today is you're going to flip to the very back side of your notes where you have a blank page because I didn't leave you enough space to write this piece down. You don't have to write all of this, but you're going to need the formulas. But the question is, how do we find the square root of I? I mentioned this is coming up, but let's try to prime this in our brain a little bit. What is I squared? -1. What's the square root of 25? 5. What's the square root of -25? 5i. What's the square root of 25i? You have no idea. Exactly. Thank you. All right, so we don't know. So let's go back and kind of review this, okay? We want to find the roots of complex numbers. Here's what we discovered yesterday. Suppose that we have trigonometric form of a complex number. We learned that we could raise that complex number to a very large power. In fact, yesterday we raised one to the 100th power, correct? And we made it look quite easy. Do you remember the formula that we used there? We said you take r to the nth, very good, and then you add cosine of plus I sine of. Hey, yeah, isn't that great? Look at what you kind of recalled and remember. That's really good stuff. So what we're trying to do today is instead of raising something to nth power, instead of say squaring something, we're going to take the square root. So instead of taking it to the 2 power, we're going to take it to the 1/2 power. So the question is, suppose we have z and we want to raise it to the 1/n power. What do you think we do with r? R to the 1/n. Good, times cosine of. Close. This is where it falls apart a little bit on us. You have the theta, you have the divided by n, but we have something else up here. It's plus 2 pi k. And I wish that I could give you a really good reason of why that is. Best bet would be to really go through the reading in your book. Yeah. Okay, because it would take us quite a while to go through how this formula is actually produced. All right, the proof is rather strenuous for us. So you really just need to trust this formula. It's very similar to Denominators formula, but you got this 2 pi k piece here. We have plus I sine of theta plus 2 pi k divided by n. Now, as we read that formula out, there's a question that should be coming to your brain, and that is, what is k? Very good. So here's what we say k is. K is the integers 0, 1, 2, 3, ... all the way up to n minus 1. Now, what the heck does that mean? Here's what it means. Suppose I'm finding the square root. What would n be if I'm finding the square root? 2. Okay? So k is n minus 1. What's 2 minus 1? 1. So k will be the integers 0 and 1, which is how many integers? 2. Let's do a different one. Let's do a 5th root. Suppose we're doing a 5th root. What is n? N is 5. 5 minus 1 is. So therefore, k would be the integers 0, 1, 2, 3, and 4. See that? You still come up with 5 total. Yeah. So if we take the 6th root, you come up with 6 solutions. Okay, k has 6 parts to it. We just start at 0 and we end 1 before an integer. So the idea is this produces n roots. The roots are w sub 0, w sub 1, w sub 2, w sub 3, w sub n minus 1. So the cool part here is that if there's a square root, it's not that there's just one square root, there are 2. If there's a cubed root, there's not just one cubed root, there are 3. If there's a 5th root, there's not just one 5th root, there's 5. Whatever root number you're producing, that's how many roots actually exist for that part. Okay? So, we're going to see this play out in the formula. I have the formula written behind me on the board so you can reference it. But we're going to walk through 3 examples. Now, note, you get a full workday tomorrow because, again, this is, I believe, the most challenging piece of content that you get to all year. Great day to come in and see. Yeah. All the integers up until n minus 1. Yeah, just include 0 and stop 1 before it. And we'll see it play out. Flip back to your notes. Here we go. Okay, so earlier I asked you the square root of 25 is, square root of negative 25 is, and square root of negative 25i is, you have no idea. So we are trying to find the square root of negative 81i. That's our goal right now, the square roots. So here's where we start. We need to be methodical in our work. Otherwise, this is just going to completely fall apart on us. We start off by identifying n. What is n? 2, because we're finding the square roots. Very good. So square roots would be 1 over 2. Agreed? So therefore, n is 2. That's the number of solutions. Therefore, k will assume what integers? 0 and 1. Okay? Now, in order to make a go at this, I have to transform this into trigonometric form. In order to transform 0 minus 81i into trigonometric form, what 2 things do I have to determine? R and theta. Very good. How do I determine R? Square root of a squared plus b squared. What is a squared? 0 squared plus negative 81 squared. I'm not going to calculate that. The square roots of negative 81i. So if we write that as a complex number, it's 0 minus 81i. We don't have a real part. We only have an imaginary part. Agreed? Awesome. 0 squared is? So I'll end up with the square root of 81 squared, which is 81. We will always leave the principal roots of the positive root. Okay. Theta, as we determine theta, we set up what formula? Tangent theta is equal to? So it'll be negative 81 divided by 0. What is negative 81 divided by 0? Undefined. Oh no, if anybody can tell me where is tangent undefined? 90 and 270. So am I sitting at 90 or 270? Why am I sitting at 270? Because when you plot it, you are along that y-axis down below. Very good. So I need to convert it to radians. 270 in radians is 3 pi over 2. You guys are amazing. Way to go. So now we can write it in trigonometric form. In all of its beauty, cosine of 3 pi over 2 plus I sine of 3 pi over 2. Sweet. Okay, very good. Here we go. I now need to go to work. I'm going to find the value of W sub 0. So I'm going to start out with my formula. I have W sub 0, and I take R, which is 81, and what do I do with that? I raise it to the, which is, raise it to the 1/2 power. Good. So we're just going to take our time and really just focus on plugging in numbers. Okay. Then cosine of, it says theta, which is 3 pi over 2 plus 2 pi k. What's k? k is 0, and 2 pi times 0 is 0. Yep, yep, yes. We will use the k that's 1 after we use k that's 0. W is just a variable to represent your root number. Don't worry about it. All right, divided by what? 2 plus I sine of. Now, this is where I like to save a little bit of space because I like to stay organized. You guys know how organized I am. So, okay. So 3 pi over 2 plus 0 is 3 pi over 2. Then we're going to divide that by 2. Watch, I'll write it out. We have to get used to this, otherwise we'll waste a lot of time. 3 pi over 2 divided by 2 over 1. So you multiply by the, and you get 3 pi over 4. So if you take 3 pi over 2 and divide that in half, we get 3 pi over 4, because you multiply by the reciprocal. Yeah, I wasn't going to write this whole thing again right there. I just used some space to simplify. And now I'll continue on that track. 81 to the 1/2. 9. Hey, we're getting close here. Times cosine of, what does that simplify to? 3 pi over 4 plus I sine of 3 pi over 4. Hey, that's actually trigonometric form of our answer. The problem is we don't want to leave it in trigonometric form. We want to place it into complex form. That's what we did right at the end of yesterday. So if only we knew what the cosine of 3 pi over 4 was. 3 pi over 4 is how many degrees? 135 degrees. What is the terminal point of that location? Negative root of 2 over 2, root of 2 over 2. Yeah, you guys got it. So we got cosine of 3 pi over 4 is what? Negative root of 2 over 2 plus root of 2 over 2i. We could just distribute that 9 right through, couldn't we? So first of all, do you know that 3 pi over 4 is 135 degrees? You would have to multiply that by 180 over pi and convert from degrees to radians. So then you have 135 degrees. So you need to recognize that that is a 45, 45, 90 triangle. And then we produce the negative root of 2 over 2, root of 2 over 2. Better? Yeah. The circle of life, which some people call the circle of death. Very good. You are lying. Negative 9 roots of 2 over 2 plus 9 roots of 2 over 2i. That is my result. As I have it, somebody tell me what the heck does that even mean? No, because it's got an I on it. Ion on it. It's got a... Yeah, very good. If you were to take this and multiply it by itself, you would get negative 81i. Yeah, exactly. Exactly. So when I was your age, I knew you were on my side. Great. Okay. So Jessica, now is when we're going to take that W sub 0 and remove the W sub 1. Yeah, so there's 2 solutions. We said that. It's the square roots. Then there are 4, yeah. Yep. So we did 0, and now we're doing 1. And then we're done. Okay, does the front change? No, it's still just 9, right? But here's where we got to pay very close attention. Cosine of, what's the theta value? 3 pi over 2. Wait a minute, how did you get 2 pi? How did you get 1? So k is now 1. So therefore, it's 2 pi times 1, which is 2 pi. So that's what changed. Divided by 2. The rest of it stays the same. Plus I sine of, oh my gosh, how do I even do that? Okay, so you're finding common denominators. So 3 pi over 2 plus 4 pi over 2 is 7 pi over 2 divided by 2 is 7 pi over 4. How did I get what? K was 1. So 2 pi times 1. We good? 9 times cosine of 7 pi over 4 plus I sine of 7 pi over 4. Shoot, if only I knew the exact value of cosine of 7 pi over 4. We do? Wait a minute. Oh, that's 315 degrees? That's a 45, 45, 90. What's the terminal point there? Oh, that's pretty handy, isn't it? I mean, it's like... So we got 9 times root of 2 over 2 minus root of 2 over 2 times I. Or 9 roots of 2 over 2 minus 9 roots of 2 over 2I. No. The results will often be similar, but they will not always be exact opposites. In case of square roots, they should be. They should differ by a factor of -1, because obviously if you square -1, you get 1. Okay? So, do you have the general idea? Yeah, it's a lot, right? Like, I couldn't ask you 8 questions like this on the test. Right, exactly. Like when you're watching the movie and there's somebody really intelligent, well, you're that person. You're going to Harvard. All right, Miss Gregory, you are welcome to stay as long as you like, but it's pretty much going to be, yeah. Thank you. All right, so find the third roots of -27i. We're going to make this even easier than the last one. Watch me go. What is n? 3. What is k? But we're going to be super smart about it. You're trying, look at what you're trying to do first, folks. You're trying to find the cubed root of -27i. All right? If you were to plot -27i, how many units would it be from the origin? Yeah. Look, the radius is always positive. So. And if you were to plot 0, -27, what angle would it place you at? 270, which is? Okay, I'll show you. Would you agree that this point is 0 minus 27i? So would you agree that that would be a point right here at -27? So do you see it's 27 units from the center? Now, if you want to go through the work of square root of a squared plus b squared, you can. Or you could just say, oh yeah, it's going to be 27 units from there. Second of all, if you want to go through the work of tangent of theta is equal to b divided by a, and see it's undefined, that's fine. Or you could say, oh, I'm right there. That's 3 pi over 2. Yes. A squared plus b squared. Watch. Better? definitely not there. Okay, here we go. I now have trigonometric form. 27 times the cosine of 3 pi over 2 plus I sine of 3 pi over 2. Is there somebody who can tell me what to do next? What do I write? W sub 0 is equal to 27 to the 1/3 power. No. No? Very good. It's over 3. Plus I sine of pi over 2. Better? What is 27 to the 1/3 power? That's trigonometric form. Let's turn in complex form. What's cosine pi over 2? So this is where you have to locate. What happened there? This is where you have to locate this point, which is 0, 1. Is cosine the x value or the y value? It's the x value. So cosine of pi over 2 is 0. So you end up with 3 times 0. What's the sine of pi over 2? 1. And 1 times I is I. So therefore you get 3I. Now if you think about the original problem, what's 3I times 3I? Negative 9. What's negative 9 times 3I? Negative 27I. So that's the one that could kind of appear a little bit obvious. But how many more solutions do we have? We have 2 more solutions. So what do we write down now? W sub 1. What is going to be the front term? 3 times cosine of 3 pi over 2 plus 2 pi all over 3 plus I sine of 3 pi over 2 plus 2 pi, 7 pi over 2 divided by 3, 7 pi over 6, pi over 6, how many degrees? 210, which leaves what kind of triangle? 30 degree, 30, 60, 90. What is the terminal point? Very good. So I have 3 times negative root of 3 over 2 minus 1 over 2I, which is negative 3 roots of 3 over 2 minus 3 over 2I. So I have 2 solutions. Now what? W sub 2 is 3 cosine of pi over 2 plus 4 pi over plus I sine of 3 pi over 2 plus 4 pi. 11 pi over 2 divided by 3. 11 pi over 6. That gives me 3 times the cosine of 11 pi over 6 plus I sine of 11 pi over 6. 11 pi over 6. 330, which leaves me with what for a terminal point? Root 3 over 2, negative 1/2. Very proud of you. It's your birthday. And I get, whoop, it's a positive root of 3 over 2, right? Made that mistake. My bad. Sorry, folks. 3 roots of 3 over 2 minus 3 over 2i. Who knew it? But if we take that and multiply together 3 times, you get negative 27i. Last one. All right. So this is kind of what I started out this class with. If you remember day one, I said, some of you guys think you really know a lot about mathematics. You guys, you did and you still do. But I wanted to, show you. I said someday during the course here, I'm going to teach you how to do the fourth root of -1 plus I roots of 3 over 3. And that means what do you multiply by itself 4 times to get that? And you looked at me like, I mean, that just seems impossible. But here we are. We're able to do it. Takes a lot of math to be able to figure that out, though, doesn't it? A lot of prerequisite skills. So we're not going to quite do all 4, but we are going to set up for sure the first 2. What do we say n is in this situation? So therefore, k is stop laughing, Alex. All right, so here we go. We're going to find r, and we're going to find theta. Oh, boy. 1 plus 1/3, because if you square the root of 3, you get 3. And if you square 3, you get 9. So 1/3. So very good. You get square root of 4/3. And that doesn't come out to be anything nice, does it? No, it's pretty ugly. So I'm going to leave it as the square root of 4/3. And you're going to see what we're going to have to do in this type of situation. It would be 2 over the root of 3, or 2 roots of 3 over 3. But for our purposes, it doesn't really matter. And you're going to see why when we come up with the angles here in a little bit. Okay? So let's find theta. We have tangent of theta is equal to b, which is root of 3 over 3, divided by -1. Negative root of 3 over 3. So where is tangent negative? Second quadrant, very good due to your location. Good job. If I inverse the root of 3 over 3 for tangent, I get back one, up the root of 3 over 3. If I inverse the root of 3 over 3 for tangent on my calculator, I get 30 degrees, which is what for a solution? 150 degrees, and then convert that to radians. 5 pi over 6. So therefore, we have the root of 4/3 times the cosine of 5 pi over 6 plus I sine of 5 pi over 6. And if I left my answer like that, that would be incorrect because the denominator is not rationalized, but that's not the final answer, is it? I'm simply going to use that in my work. So w sub 0 is then equal to, what do I do with the root of 4/3? And I got the root of 4/3, and I raise that to the 1/4 power. So does everybody agree that that's just going to come out to be some icky decimal? And that's all we can really do with it. Okay, then we get the cosine of 5 pi over 6 plus 0 divided by 4. What's 5 pi over 6 plus 0? What's 5 pi over 6 divided by 4? Yeah, so this is the first time we've come up with an angle. Can we find the exact value of sine of 5 pi over 24? We don't really have that in our repertoire, do we? But you could find the exact value of 5 pi over 6, right? You could use a half angle formula and do then 5 pi over 12. And then you could do another half angle formula and do 5 pi over 24. But that would just be ridiculous, wouldn't it? So at this point, if you come up with an angle that doesn't lie with one of our unit circle reference values, like 30 degrees, 45, 60, you just transfer it into a decimal. And so watch what I'm going to do here, okay? I'm going to turn all of these pieces into a decimal, and that's going to help me out, okay? I'm going to first find the decimal for that radius portion out front. The square root of 4 divided by 3. And I get that. I need to raise that to what power? Raise it to the 0.25 power, and I get 1.0366. Parentheses. And then we know that cosine of 5 pi over 24 is not a nice value, is it? So therefore I do cosine of 5 pi divided by 24. And I get, I don't think I'm in radians. Yeah, I am. Okay, 0.793. And then I do sine of 5 pi over 24. And I get 0.61. So now what I'm going to do is I'm going to distribute the 1.0366 to each part. 1.0366 times 0.793. And I would like you to write your answers to the nearest hundredth. So 0.82. And then 1.0366 times 0.61. And I get 0.63. Yeah. So, yep. Well, I mean, that's part 1. We still have 3 more, which we're only going to lay out the second part. We won't do all 4. But what does that mean then? If I were to multiply that 4 times, I would get -1 plus I root to 3 over 3. Which seems absurd, but it works out that way, okay? Let's do one more, and you can see how nicely this works out now. We have then W sub 1 is equal to, what stays out front? Yeah. Times the cosine of, so we just have to change the angle. 5 pi over 6. Five pi over 6 plus 2 pi. 17 pi over 6 divided by 4. So I have 1.0366 times. I now need the cosine of 17 pi over 24. Negative 0.61. Sine of 17 pi divided by 24. 0.79. I. I'm going to multiply those by 1.0366. And you can see I get negative 0.63. And 0.79 times 1.0366, 0.82. that similar? It is. And you can then see how the next two would just follow suit accordingly, right? And there you go. So, William brought up a great point. First of all, your assignment is, William always brings up great points. There's your assignment. You have a full work day tomorrow.